Welcome to Ushendra's engineering tutorials. An important topic from signals and systems, signal analysis. It's something about Fourier transform, and we have a lot of many properties in Fourier transform which makes the analysis even more simpler. So one of the important property in Fourier transform is a duality property. A lot of applications. Trust me, you got a lot of application from duality property. Okay, so if you got to rate the topic, it's 5 out of 5 topic. Yeah, that's that important in Fourier transforms. So what is a Fourier transform actually? What will be given and what should be evaluated? What transformation happens from what to what? X of t, the time domain signal, the continuous time domain signal, not the discrete one. Okay, for the time being, it's a continuous time. The continuous time signal x of t will be given. So the Fourier transform of this one, the Fourier transform of this one, denoted with x of omega, j omega by some authors, and straight away x of simply omega by some other experts. Don't get confused. Which is equal to, how to evaluate this one? The given signal x of t, the given signal x of t, it's x of t multiplied with e raised to minus j omega t integrated from minus infinity to its integration, okay, plus infinity with respect to t. Guys, this is the procedure. The actual process starts from this one. Whatever signal, now this one, this is like whatever signal, whatever given signal, it's when it's multiplied with e raised to minus j omega t and integrated from minus infinity to plus infinity with respect to t, that's the conversion Fourier transform. Here a time domain signal is converted into frequency domain, omega 2 pi f, we have that omega equal to 2 pi f, isn't it? F, we have frequency of that, so this is the conversion. Okay, so what about duality property? Guys, stick to here. What do we have? And yeah, in this very context we need to talk about inverse Fourier transform also. So how to extract x of t? If x of t is given, the conversion, the time domain to frequency domain conversion is obtained making use of this one. So what if x of omega is given? How to extract x of t? And so in applying inverse Laplace transform, that will give us inverse inverse Fourier transform. Sorry to switch to Laplace transform. It's a inverse Fourier transform will be of what's that? X of omega will give us x of t, which is equal to, guys, from the making use of this formula, it's x of omega, it's multiplied with e raised to j omega t and integrated from minus infinity to positive infinity, and with respect to what? It's d omega. Okay, and we have an average over here 1 upon 2 pi. Guys, this is the expression to extract the time domain signal from frequency domain signal. Okay, so this is for the inverse Fourier transforms, right? And why the need of where do we find the need of duality property? We cannot evaluate some Fourier transform of some functions will be not converging, some constant. The Fourier transform of a constant will not be converging, it becomes infinite. But don't we have a Fourier transform for a constant? We have. So by making use of duality property, we evaluate the Fourier transform of a constant. There are some other applications to derive the Fourier transform. Straight away cannot evaluate the Fourier transform making use of this one, and such a function can be the Fourier transform of such functions can be evaluated making use of duality property. The duality property will start from here itself, from the inverse Fourier transform. It's x of t, rewriting it again, 1 by 2 pi integral minus infinity to plus infinity x of omega e raised to j omega t d omega. Guys, in maths it's we have that whatever we do in the LHS, that can be done, through the entire expression, the changes, whatever we want to do, that changes if it's done throughout the entire equation, that doesn't change the characteristics of the complete equation, isn't it? So here it's what if substituting t equal to minus t on either side of the equation. That can be done, right? Substituting t equal to minus t. So if this is the case, if I want to go for this change, here we have x of minus t. T is plugged in with minus t, okay? So which is equal to 1 by 2 pi, no change in that, integral negative infinity to positive infinity. It's x of omega as it is, and there is a small change over here. It's a negative t, isn't it? So that will be minus j omega t and dt. Sorry, d omega. I'm sorry, I'm correcting it. So d omega, right? Straight away over here. Yeah, fine. Now another change throughout the entire expression. Another change throughout the entire expression, not only sticking to LHS or RHS. Okay, throughout the entire expression. What's that? Wherever I find t, I'll be plugging with omega throughout the entire expression. Okay, so that gives me x of t is with minus omega, which is equal to, and guys, if this is the case, what will be our dt? If this is if I go for t equal to omega, dt will be equal to d omega, isn't it? We need this one. We need this. Can you see? We have that one, so we need to go for that one also. So plugging in t equal to omega and omega equal to t through entire expression. Okay, so that gives us 1 by 2 pi is 1 by 2 pi integral negative infinity to positive infinity. Yeah, here we have to be more cautious. T equal to omega, so omega will be equal to 2 x of t e raised to, guys, it's no change over here. Why? Because we have omega and t, so that will be as it is, minus j omega t. And now we are making use of this one, dt will be equal, d omega will be equal to dt here with the substitution dt. Okay guys, this is one. And if this is the case, can we write like this one? It's dividing over this side, going that side, it will be multiplying. So can this be written as 2 pi into x of minus omega will be equal to, here I need your attention, more attention. It's gone that side, so we have negative infinity to positive infinity, and here x of this capital X of t, uppercase X of t, is multiplied with e raised to minus j omega t and integrated with respect to t. So guys, what it is? This entire expression, what it is? Right? X of t is multiplied with e raised to minus j omega t and integrated from negative infinity to positive infinity with respect to t. So what is this? This gives us, which is equal to the Fourier transform of x of t. Guys, this is the one expression for that which we are searching of, duality property. F of Fourier transform of x of t will be equal to 2 pi. As even more, if the function, if that function, which is that function, if x of t is even, now this won't be anymore, this will be 2 pi as it is, it will be x of omega. Okay, sine minus theta, that will be minus sine theta because it's negative, it's a odd function. Cos minus theta, that will give us cos theta, isn't it? So in that way, if it is a even function, this will be the transformation. It won't be negative anymore. It's a 2 pi into x of omega, which is equal to the Fourier transform of x of t. Regarding that, was that final show for duality property? F Fourier transform of x of t will be equal to 2 pi x of omega if it's negative, if it's a even function. So where do we find the application of here? Before going to that, a small Fourier transform of a very important function, impulse function, right? Impulse, this is the one, impulse function, unit impulse function with a t equal to 0, etc., t extending from negative infinity to infinity. This exists only at t, the impulse function exists only at t equal to 0. So how to put that in a statement, equation, something, representation? It's the representation del of t will be equal to what? It's 1 only for t equal to 0, and it's 0 when t not equal to 0. That's the way we represent this one. Okay, this function, the impulse function, exists only at t equal to 0 and not any other place. So what will be the Fourier transform of this one? Fourier transform of del of t will be equal to what? It's a del of t multiplied with e raised to minus j omega t and integrated from minus infinity to plus infinity with respect to t dt according to the formula, right? According to the formula of evaluating Fourier transform, this comes into the picture. But this function is equal to del of t is equal to 1 only at t equal to 0. We don't need any integration. In the sense, what is that function? It's a 1 into e raised to minus j omega t at t equal to 0. In the sense, it's a 1, e raised to 0, that will be 1, and this is the 1. Okay, our Fourier transform of here, Fourier transform of impulse function del of t will be equal to 1 into 1, that's 1. Okay, this is the way to evaluate the Fourier transform of an impulse function. Guys, in all the transforms, let it be a Fourier transform, let it be a Laplace transform, let it be a Z transform, in whatever transformation we have, the transformation of impulse function will be unity only, one only. Keep that in mind. Okay, let it be. Now it's a Fourier transform. Even in Laplace transform, that's the same result. Fourier transform of any constant function, constant, let it be one, unity throughout, extending from minus infinity to plus infinity. Fourier transform of 1. Fourier transform of 1. So how to evaluate according to the formula? 1 into this, the given function is multiplied with e raised to minus j omega t and integrated from minus infinity to plus infinity with respect to t dt, isn't it? So now what will be that? It's a 1. So integrating with respect to here, this one, this it's a 1, so that's okay. Integrating this term with respect to t, e power x, integral e power x, that will be e power x upon a, isn't it? If x is treated as a variable with respect to t. So this one, this comes down. Let's do it. It's a e raised to minus j omega t upon minus j omega, because integration with respect to t, and we have minus infinity the lower limit and positive infinity the upper limit. So plugging in the values of lower and upper limits in place of t, okay, that gives us, guys, that will lead us to minus j omega. So with the upper limit, it's e raised to minus everything into infinity, right? That leads us to negative into positive, that's negative, infinity, this infinity, infinite, so the everything infinite. Okay, the lower limit, it's minus of e raised to minus into minus infinity, that gives us positive infinity. So e raised to negative infinity, that's 0, okay, but the problem is with this one, yeah, minus of e raised to infinity, what it is, it should be infinity, right? It's not converging. Minus j omega, that's infinity, it's not converging. But don't we have the Fourier transform of the constant 1? We have this, it's not converging. Making use of the duality property, we can evaluate the Fourier transform of the constant. Fourier transform of 1, it's not converging, isn't it? Making use of the actual formula. So that does this mean that don't we have the Fourier transform of the constant 1? We have. Making use of the duality property, we can evaluate the Fourier transform of this function, not the straight away, but making use of duality property. Just now we have seen what is the Fourier transform of the impulse function del of t. It's 1, isn't it? right? So I need only this one. So what should be done? It should be applying, I mean, going for the inverse inverse Fourier transform, of 1. This goes away, and so we have how to evaluate the, what is that equation to evaluate the inverse Fourier transform of this one? It's a inverse Fourier transform. This one will be 1 upon 2 pi integral minus infinity to positive infinity, whatever given function, 1 into, it's the given function is multiplied with e raised to positive or negative, positive j omega t, and with respect to omega, right, d omega, isn't it? On this side, what do we have? It's a del t impulse function, right? So now in this case, the same procedure which we evaluated for the duality property, t equal to minus t, and throughout the entire expression t equal to minus t. So that gives us del of minus t is equal to 1 by 2 pi integral negative infinity to positive infinity. Guys, it's a 1, so straight away 1, okay, 1 into e raised to, it's a t equal to minus t throughout the entire expression, so that will give us, it's a minus j omega t d omega. Okay, now the next step, it's a t equal to omega wherever I find in the expression, t equal to omega in the LHS as well as RHS. Okay, and with this one we have dt equal to d omega. Okay, so with this one, with t equal to omega, dt will be equal to d omega. That gives me here, it's a del of minus omega, which will be equal to integral minus infinity to positive infinity 1 into e raised to minus j omega t. Guys, we have t equal to omega, we have both over here, so that isn't a big deal, so don't get confused. Nothing change over here. Plug in with omega equal to t, that will be reversed, it continues, and d omega, it's a dt. Guys, what about this one? What is this doing over here? 1 by 2 pi, can that be brought to this side? Can this be this? It's dividing, so it will be multiplying on this side into, isn't it? So guys, have a careful look at this one, this expression, this one, this function 1 is multiplied with e raised to minus j omega t and integrated with respect to, I mean, integrated from negative infinity to positive infinity with respect to t. What is this? This is the Fourier transform of the function 1, and on the other hand we have this one, and it's a impulse function and it's a even function, and so our expression will be 2 pi into del omega. Yeah, this is the important application of duality property. Making use of this one, that didn't converge, right? That became infinite. But don't we have the Fourier transform of this one? Yeah, we have the Fourier transform of the constant, that's evaluated making use of the duality property. Make a note, please. Now what will be the Fourier transform of the signal e power e raised to minus a t u of t? What if this is, what if we have to evaluate the Fourier transform of this one? This has got a significance, isn't it? It's a step function extending from t equal to 0 to infinity, and so with that, when the signal is whatever the function is multiplied with this one, the limits of integration changes, isn't it? So that's what, according to that, I mean, the Fourier transform of this one should be like 0, I mean, integration e raised to minus at into e raised to minus j omega t integrated with respect to t, so dt. But because of this one, it's a 0 to infinity, because u of t is a step function extending from t equal to 0 to infinity, and this whatever signal is multiplied with this one, so this, even this signal will be existing from 0 to infinity only. Okay, so it's a pre-calculated thing, taking out common It's integral 0 to infinity e raised to, guys, should we take out negative or positive as a common over here? It should be negative. Why? Because plugging in 0, that will be 1, but plugging in the upper limit positive infinity, that should converge, and so we take the negative as common from here. If we take out positive as a common, that would be positive infinity, and the function doesn't converge. That's the point over here. It's a negative as common, so it's a plus j omega into t dt, isn't it? So straight away integrating that will be e raised to minus of a plus j omega into t by with respect to t. So this comes down minus of a plus j omega comes down, isn't it? Because, and yeah, why did I stop over here? This isn't the final one. We have the limits 0 to infinity. Why can we how can I neglect that? I cannot, isn't it? So here, so minus of a plus j omega in the denominator as it is, plugging in upper limit e raised to minus infinity, straight away I'm plugging in, okay, e raised to minus infinity, that will give us 0, minus of lower limit e raised to 0, that will be 1. So this negative gets cancelled, and our final result is 1 upon a plus j omega. What's that? The Fourier transform of the signal e raised to minus a t u of t will be equal to that much, 1 by a plus j omega. Okay, so guys, this isn't, we are not yet done. I wanted to explain something else from here. This is not the, okay, we need the derivation, but another important concept, another important question picked from the previous, a repeated question from the previous question papers. What I wanted to prove is, guys, it's now here, yeah, Fourier transform of rewriting over here, Fourier transform of e raised to minus at u of t was evaluated to be what? 1 upon a plus j omega. So what if we apply inverse Fourier transform on either side? Inverse Fourier transform on either side. Inverse and the Fourier, this gets cancelled. So we have this one, inverse Fourier transform, this one. So how to evaluate the inverse Fourier transform? LHS we have e raised to minus, guys, it's a partition, okay, please don't mind, minus a t u of t, which is equal to what? So how to write, how to evaluate the inverse Fourier transform of this one? The given function 1 upon a plus j omega is multiplied with e raised to j omega t and integrated according to what? According to inverse Fourier transform. It's a minus infinity to plus infinity, and 1 by 2 pi inverse, right? And d omega, the formula to evaluate the inverse Fourier transform. And what if we have t equal to minus t throughout the equation from this end to that end? That gives us, this will be e raised to at. Why? Because this negative and this negative, that becomes positive. U of minus t will be equal to 1 by 2 pi integral negative infinity to positive infinity 1 upon a plus j omega e raised to minus j omega t. Why? Because t is plugged in with minus t, so minus comes over here, t there, d omega. Okay, now guys, same duality property, t equal to omega, and that gives us dt will be equal to d omega. And with this transformation we have, guys, wherever t, we plug in with omega and converts. Okay, and that, in that case, this becomes e raised to a omega, it's omega, u of minus omega, am I going correct? Of course, which is equal to integral minus infinity to positive infinity 1 upon a plus omega with the t, jt into e raised to minus j omega t. There's no transition, because why? Because we have both the terms, and d omega will be equal to dt. From here it's a dt, and yes, I didn't forget about this 1 by 2 pi. I didn't. So that will be 2 pi over this side. Okay guys, what is this? What is this? What's happening over here? This. So it should be, guys, I'm very sorry, I'm taking it back. That's no more omega, that will be t. Okay, so guys, I have corrected here. Okay, I did a mistake, but I corrected over here. So what is that? It's a Fourier transform of 1 by a plus j t, isn't it? This function is multiplied with e raised to minus j omega t and integrated from negative infinity to positive infinity with respect to t, and so that will give us the Fourier transform of this function, which is equal to what? It's 2 pi e raised to 2 pi into e raised to a omega u of minus omega. Guys, this one I wanted to show you this. It was asked to show that the Fourier transform of this one is this. A very repeated question from the previous, picked from the previous question papers. So a very important one, guys. Hope you understood the analysis, calculation, whatever you call it. Please support me with your valuable share and a subscription. Thank you for watching.